Oh, good evening. Thanks for watching. I left my dock at work, so I have to do it. Basically, the aspect ratio is a little bit messed up, but I'm working today more on my stock market tool. Um, Let me go through the PowerPoint really quick. Yeah, this is it. And I'll explain what I've done and what I'm going to do moving forward. So, the goal here is to get basically a quantitative strategy to make money off of the stock market. Um, oh, wait, I don't think I put my my face isn't on there. There we go. Um, yeah, so the goal is to get a quantitative model for the stock market, make money on the stock market, and my goal is to beat the S&P 500 by a significant margin. Um, so first step was getting data. I started out with data from NASDAQ. They make you download CSV files, which just isn't going to be efficient for large scale stuff and for updating every day. I want to have a model that updates after the market close to get buys for the market open, and then I can set the buys to purchase at market open. And so I found a better database on DoltHub. The link is in the description if you are interested in it. Um, but this is updated every single day. This guy updates the database after the market closes. There's all sorts of features in there like fundamental data, price data, options data, basically everything you could want in terms of price data. Nothing paid though, so that was one of my requirements. Is everything has to be free because I want this to be usable for other people. So I looked at some basic analysis here. Um, I was looking at the this is fundamentals here. And this is basically I made some functions that you can add any stocks you want to a sector and then look at how the stocks perform against the average for the sector. This is all really qualitative stuff and you can't really automate it. And so the next step was building a LGBM model, which is a light gradient boosting method. It's very effective for stocks. It handles missing values well, it handles time series very well, and it's really efficient. Um, and so you see here, this is one model that I got. The best I was able to get is about 51.5% directional accuracy. Picking up or down, that was right about 51.5% of the time. And I did get some portfolio strategies to work. So one thing I found is that if I'm picking the lowest end volatility stocks in my universe, the fewer number of stocks I pick, the better it performed. You see here 500 stocks is underperforming the S&P. 100 stocks is basically matching the S&P. 20 stocks is outperforming the S&P, and one stock is way outperforming the S&P. I looked at this on this plot here to see, is there some ideal number of lowest volatility stocks to plot? And I want to see if we get a Sharpe ratio above 1. Basically, if the Sharpe ratio is above 1, it's considered usable, but you would like something significantly above 1. And so I plotted, um, x-axis here is number of positions. So 50 means it's taking the 50 lowest volatility positions. And then the y-axis is the Sharpe ratio. And you see this is 1 right here. So the only thing that has a Sharpe ratio above 1 and is considered usable is if I'm picking one stock per day. And I refined this a little bit. I looked at, if so this is regression. So it's picking the uh, well, this regression to a probability. So this is the probability of a positive return for the day. So if I thresholded the positive return, just at 0.5, you see here it's about 1. 0.51, it performs the same. 0.52, same. 0.53 though is significantly better, and 0.54 is above 2.5 Sharpe ratio, which is really robust. Um, but the problem here is that 0.55, I'm picking no stocks. And so this isn't making it many picks. And at the end of the day, it's just making one pick per day, which is a really risky strategy. So I wanted to go through basically, this comes back down to I need a better model because 51.5% directional accuracy, I'm going to be really limited in what I can do. I want to get something that's 53 or 54% directional accuracy. So I needed to rapidly iterate through the models. The problem was my code base wasn't very well organized, and I was having every time I wanted to change how the universe was defined, train the model differently, or implement a portfolio strategy, I had to make a new file, which resulted in dozens of files. And if I'd continued down this path, it would quickly blow up into hundreds of files. So the last month, I've been working on organizing this all into a clean, usable class that not only I can use, but anyone can use. Again, I have several goals here. One is to make money. Two is to have entertaining live streams, and three is to make some coding tool that anyone can use. Because at the end of the day, it's kind of hard to implement these sorts of methods. And so ultimately, I'd like to integrate it into a GUI and just have an app where anyone could go train their own models however they want. And so I already had clean data. I wrote some classes for filters to feed into the stock universe. I wrote a class for the stock universe, which basically retrieves it however you want. That's going to get fed into the returns model. The most intensive work was making feature and target classes I wanted to do every possible feature and target I want. And so this is all the features and targets that I incorporated here. Magenta were things that I wasn't really able to do, so I left off for the future. I still have to incorporate, and so I'm training this on price data. So this was version 1 of the model. Version 2 of the model, this is only training on price data, but I'm limited in the features that I used. And so I got every possible price data feature I could want. And version 2 of the model is going to train on price data. So I'm going to see, basically I did this model. The best I was able to do is 51.5%. I want to see if I rapidly iterate with all sorts of features. Can I get 53 or 54%? And then I want to see how do the fundamental features do if I only feed those into a model. So I'm going to have to make a whole bunch of new features and targets for that. And then finally, what's the last point? And finally, I want to incorporate all of that stuff into a model. And I'm going to basically be tweaking and tuning it until I get 100%. So now that I have this part done, I'm working on making a model, but I've gotten stuck. So yesterday when I'm looking at the model, it's inconsistent. When I was running the model last night, sometimes it shows only 2 features. Here it's 3 features. Sometimes it's 4 features. So why is it varying around the number of features that it's getting? So that's what I'm working on tonight. The data, this is the original model. So you see this is all the files here. It's a big giant mess. You can't tell what's going on, and it's not really usable. So I organized. So this is a fork of my, this is another profile I have, but it's a fork of this repository. And this is the one that I've updated. And you see this is a lot cleaner. I added some instructions for using it. And so we're getting there. It's becoming usable. So, oops, I shouldn't show that. All right, now let me, I want to add oops, I don't want to look at that, but I do want to put a chat in the live stream and say thanks for watching. I work on this project every day. Please subscribe if you'd like to follow along. Exclamation. All right. So why do I not see that? Oh, there it is. Yeah, so let me run the model. All right, and what test were we on? It's just tests.py. Okay, so this will take a little bit to run. So one thing I need to do, I added some issues here, basically things to do. And this is a big thing, adding save functionality for model and universe. So you see this takes a while. Every time I'm running this test, it's going through and getting the universe. And this is only getting 6 months. So this model is not going to train. It's not going to be a great model because it's only training, or I'm only getting 6 months of data. And let's see, how do I split it? So 70% of the 6 months is the training data. 15% is validation data, and 15% is test data. So 6 months, 70% of 6 months is like, I don't know, 4 months maybe. So it's training on 4 months and testing on like 15% of 6 is what? 1/6 of a month plus one, so just under a month it's testing on. So this is not going to be really useful, but I want to look at the model keys. Oh, model.data.keys. Why does this chat thing keep disappearing? I'm worried there's going to be some chats and I'm going to miss out on them. Okay, so we have the target. We have this feature, 2, 3. We have the target and 4 features. Now, if we train the model, oh, there's 4 features. So let me try this one more time. Okay. Continue. See, now here we only get 2 features. What the hell is what is going on here? Alright, so let's go to Google AI Studio. Whoa, they changed how it looks? Oh, this is in Brave. Okay, here we go. My model sometimes shows 2 features in the feature importance plot, sometimes 3 and sometimes 4. Why is this inconsistency happening? Let's see. I think it should remember what I'm working on because I gave it the files. So that was last night's stream though, so maybe it's like missed that or something. I don't know. This is happening because LightGBM only plots features that were actually used to make at least one split. If a feature is never used, its importance is exactly 0. Near up 2-minute parameter space, you have this layer 1. Lambda L1. Layer 1 regularization mathematically penalizes the model for using more features. Oh. If Optuna happens to select a high lambda L1 value for a specific run, LightGBM acts as an aggressive feature selector. If Optuna happens to select a high value for a specific run, it ignores marginal features. On runs where Optuna selects a low lambda, alright, so you're using early stopping. So let's see if I could find best practices when using LightGBM on stock data. Yeah, stationary, blah, blah, blah. Archive, there's a There's papers on this. What is this guy? Oh, it's from a paper. Okay, man. Cost efficient. So where the fuck's the paper? Just give us the paper, dopey. What the fuck? If you do not want to visit that page. No. Why would I want to go there? It just gave me a different thing. Oh. That is where I want to go. Oops. Cost efficient. Song sucks. 21 Pilots suck. It's like the worst music I've ever heard. They don't have one good song. Everything's fake. This playlist sucks. Key points of the abstract. Machine learning. The application of machine learning in predicting stock market movements. Yeah, duh. When is this from? 2 years ago? That's fine. Application of... So is this the same guy, Aditya Saxena? No, that's a completely different guy. Assets forecasting with feature engineering transformation methods. So what do they talk about? Blah, 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 blah. In order to address this challenge, in this paper, we optimize LightGBM. So when's this from? You don't give a date? Show me the archive. Show me the site. Assets forecasting with feature engineering. This is really stupid how I have to keep pulling that chat box up. And there's not even any chats. But, oh, it just keeps disappearing on me. Now where did it go? Whatever. I'll just check every 20 minutes or so. I'll flip over to the YouTube. Oh, shit. YouTube. I'll just check the live stream every few seconds. Hey, it's me. Studio. Dead of the night. Oh no, not studio. How do I go back to the live stream thing? Go live. Okay, still no chats. So what was I? Oh yeah, I was reading that thing. In order to address this challenge, oh yeah, so when's this from? Best practices with feature engineering and transformation methods. (2024). I don't know how fast this stuff moves, but in physics, that's close enough. In order to address this challenge, in this paper, we optimize LightGBM and efficient implementation of gradient-boosted decision trees for maximum performance while maintaining low computational requirements. We introduced novel feature engineering techniques, including indicator price-slope ratios. Indicator price-slope ratios. Okay. And differences of close and open prices divided by the corresponding 14-period exponential moving average. All right. Designed to capture market dynamics and enhance predictive accuracy. Additionally, we test 7 different feature and target variable transformation methods, including returns, log returns, EMA ratios, and their standardized counterparts, blah, 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 blah. The results demonstrate log returns, and EMA different ratio constitute the best target variable transformation methods. Okay, so let me put some notes. I don't know where I put my watch. So today's the 27th, 2/27/2026. Notes on paper. What's this guy's name? Bisdulis. All the crazy shit I did tonight. Bisdulis 2024. For tonight, that would be the best therapy for me. Alright, so best targets. The results demonstrate. Log returns, and EMA difference ratio. With EMA ratios, return. That must be percent returns. With EMA ratios having a lower percentage of correct directional forecasts. Oh, okay. Genius. Genius finding. Log returns and returns are the best. Standardized. I don't know what that means. Moreover, the introduced features demonstrate high feature importance and predictive performance. Yeah, okay. This study highlights an accessible, computationally efficient approach. Introduction, blah, blah, blah. Related work, blah, blah, blah. Our contribution. What do? Seek to optimize the performance, shifting away from a reliance of powerful hardware. Okay, that's what I'm interested in. 7 different target variable formations. Okay, whatever. LightGBM, this will be good for me. GBDTs make forecasts by iteratively training decision trees on data. And more specifically, a base prediction, which can be the mean of the target variable, is initially used to forecast the data. A base prediction, which can be the mean of the target variable. Oh. Okay, that's nice. Based prediction. Mean of the target. Yeah. Subsequently, decision trees are fitted to the residuals of the base prediction in order to predict the errors. This process, called a boosting round, repeats until accuracy. Oh, so that might be happening under the hood. Hmm. We'll be forecasting the close price of a given day at the opening time of the market, allowing for modeling of overnight price gaps. Yeah, well, obviously that's going to help. That's going to help, but how do you even do that, guy? Okay. This paper kind of sucks. Typical price. Lag features when generating predictions. LightGBM only considers values of features at the corresponding row of data. Time series forecasting by definition uses historical data to predict a future value. It is essential, therefore, that we use past. Yeah, duh. Timestamp processing. Good, this is what I want. Grid search, commonly used in prior studies, is computationally expensive and time intensive. Come on, buddy. We'll go out after I'm done. Let me see if there's any chats. Nope. Good to go. Alright, grid search, blah, blah, blah. Instead, they're using Optuna. Very good. Faster, more scalable alternative. Balancing training efficiency with performance. We'll be using 500 trials. So what am I doing? Test model. Oh, down here. Oh no, clean analysis. Tune params. Okay, so in test, doing a classification. I still believe in your life. What does that mean? Early stopping rounds. Light GBM. Early stopping. Balancing training will be using 500 trials. How do you specify the number of trials? Optuna. Set number of trials. Okay, to optimize end trials. Whoa, I only used 20. Let's go 500. What was the directional accuracy here? Whoa, 61%. That's way too good. Oh, crap. Why am I getting 61%? Stay day and every night. Come on, buddy. Sit in my lap. We'll go out soon. Come on. Alright, so what was it? Oh, test, model. So, intraday log return. I did that yesterday. I guess, did I check that it's working properly? I still believe in your lies. Do 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 do. Bump. Bump banana. Bump banana. Bump banana. Na 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 na. Bump banana. Oh, because it's a 1 or a 0. I mean, I don't know why that shouldn't work. So, 1. So let's just look at open, close, and the target. ILRT binary. Alright, so 8285 to 8352 should be 1. It is. 8453 to 8493 should be 1. 8531 to 8432, 0. 8461 to 8317, 0. So that's fine. Oh, 61% because it's, yeah, it's, the training and test sucks, of course. Okay, so I don't think I have leakage. I think it's I'm not training on enough data. So what if I train on more data? Let's go. Baby, I will fly away. So now Uptuna's taking a long time. And the performance is the same. No. So what was I gonna do here? So, oh, let's try it with more days. So instead of training 2020 1-1, let's do the entire training set. So 2026 1-1. Oh, I think I could do 2-1 because I updated it recently. Okay, so now this is going to take a while to run. While I run this, I'm going to try to write some logic for saving the universe. Okay, so we need a file path, which should be a string. And first we're gonna, do we have OS? Okay, then we'll say if os.path.exists of fp is equal to false, raise exception file path. Let's make it a function string. File path fp. Oh, yeah, it is running. So it's up to 2017. It's not going that slow, but we still. I want to do a test and just run it. You know, just do the model part. I don't want to go get the data every time. File path fp does not exist. Okay. Then next we're gonna try pass accept pass. Okay, so what we're gonna try is I want you in my room. So I guess we don't even need a universe class, except that's... Oh, we don't need a universe class. Do I have a save function? Get all universe data. So is this a good way for doing it? Or I could just say get all universe data and then... No, that's fine. I could just save the data frame. Oh. So let's make another file. Boom, boom, boom. Okay, and then in data, I'm gonna say make directory, and what should I call it? All right, so make directory universes. Yeah, I don't know. Description, info.text. Let's go. Well, we don't need it right now. Boom, boom, boom. I want you in my room. Okay, so in here in test model, I'm gonna make a new script. And I'm gonna put it in the main directory, model explorer.py. Script for rapid prototyping of different models. And then in get ignore, I want to add this. Very good. So now we're in universes. Okay, let's get out of here. Get out of here. All right, so let's make complete universe. Okay, then let's say from import everything from feature engine, then universe 1. What's the class called? Universe? Yeah. Did this finish? Oh, now it's got... Oh, this one shouldn't take too long then. All right, universe 1 is equal to Oh, and also... Oh, I already put that as an issue. All right, so all data from saved feather. Weird. Do 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 do. All right, I'm gonna run to the bathroom real quick while this runs. I'll be right back. Whoa. Hey, buddy, I know what you want. I'll be done soon. Come on, buddy. I got some more coding to do. Up, up. Good boy. Ooh. All right, let me see. Have I missed any chats? Nope. Okay, so what am I doing here? Oh yeah, so getting universe data. how can I do this? All right, so okay, I'm just gonna add a different script actually. And this is gonna be Universe Retriever or Universe Explorer or something like that, where it can run every universe. Need a better song to power through. Give me a good song. I need a good song, somebody. Alright, so, oh, good. See, so now, you know, this is just using 4 features, and I just picked 4 random features, but you see now, before this accuracy was 61%, which was concerning, but it, like I realized, is only training on 6 months of data. Let me go to the slide from yesterday. Star. Problem was I was only giving Optuna 20 iterations. The paper on next slide uses 500 iterations. This fixes the problem. 20 iterations, which, yeah, whatever. Just leave it at that. But it's just trying to predict binary. So is that useful? I think regression would be better, but I don't have that working in the model. So let me go over to getting the universes. What is this? Oh, Model Explorer. So now let's make another one. Universe Explorer. Okay, so let's put this stuff Don't need feature engine in here. Okay, let's just import everything. Got all data. Get universe 1. Let's see, does that paper talk about the universe they trained on at all? Oh no, they just use Apple. Alright. Dopey. Okay, so now let's make the universe we have here. Then we have universe data. Let's change this back to just do from 2025-1-1 so it doesn't take forever to run. Okay. Universe data. And then we could say universe data dot to feather, and we want to save it to let's make it a function string data slash, what's it called again, universes. I guess I didn't need a function string. Master DF. Oh. I've been thing. Again, data. So the problem is it's going up a directory to look for data. So let's just call this explorers. Oh. Stock market tool. Oh. Oh. Good. Now it's getting it. And I want another baby. All that she wants. All right, let me see if there's any comments in the chat. Nothing. So that's it for now. Thanks for watching. Yeah, that's basically it. Subscribe, go to the GitHub, download it, try to use it for yourself, star it, join the Discord, also in the description. But that's it for tonight. So thanks for watching. Adios.